Hello there, welcome back. We are looking at independent and dependent events. So let's look at a scenario where we have a bag with coins, 3 blue and 2 red as shown here. Now, if in case we draw 2 coins one after the other, that makes multi-stage events. So we're talking about drawing 1 coin and then drawing a second coin. Now, when you're going to draw the first coin, then you have the option of returning the coin back into the bag and then drawing the second coin. So that is called with replacement. So one will be with replacement and the second one will be without replacement. So with the first case, when you do with replacement, then the scenario in the bag remains as it was before without having any effect of the first coin being drawn. So that would be called the independent event. And yes, if in case we want to be drawing the second coin after replacing the first coin, then it's an independent event. Whereas if in case we're going to be drawing the second coin without replacing the first coin, then that would be the dependent event. Now what happens in the dependent event is the drawing of the first coin will affect the second event, right? So let's look at this scenario where we are having 2 events, drawing 1 coin after the other, and we call them event A and event B. So event A is drawing the first coin and event B is drawing the second coin. So we're referring to these events as event A and event B. So this is event A and event B, correct? Now, if we are talking about independent events, then we're going to be replacing the coin that we drew in the first try or first event. And then when you draw the second one, you will still have the same number of choices again for the second event. Whereas in the case of dependent events, the second event B, event B, depends on what happens in the first event. So if in case we are going to be talking about the probability of event B, that is the second event B happening, given that A has already happened, that means this is a dependent event, then we will say yes, that is the same as probability of B intersection A. That's a formula that we have. We can explain that further in a separate video, divided by the probability of such that event A has already happened. Now, if in case we have independent event, this was in the case of a dependent event. If in case you have independent event, then it doesn't matter whether probability of A and probability of B is connected. So I'll put it this way, the probability of A and B happening successively would be same as probability of B multiplied by the probability of A divided by probability of A as per the formula here. Then in that case, what we have is probability of A divided by A is 1, so we get probability of B. Now what this indicates is this is a case of an independent event where probability of probability of B, given that A has happened, will be equal to probability of B. In that case, probability of B given A is nothing but probability of B intersection A, which is nothing but probability of B times probability of A. So that is the case of independent events. The probability of B, given that A has already occurred, is given by probability of B intersection A divided by the probability of A. So we'll repeat that one more time. Probability of B, given that A has already occurred, is given by the formula probability of B intersection A divided by the probability of A. Now, in the case of independent events, the event of B happening is not affected by the event A happening. In that case, the probability of B intersection A, that means probability of B and A, which is the numerator here, becomes probability of B multiplied by probability of A. So probability of A divided by probability of A will give us 1. That's why the probability of B, given that A has occurred, is equal to probability of B. Now, when we are testing for independent events, these are the two conditions that we can use for testing. If the two events are independent, or given the two events are independent, we can test these conditions to find the missing values. Probability of B, given that A has occurred, is equal to probability of B, and probability of B intersection A is equal to probability of B multiplied by probability of A.